Hey, YouTubers, Tazman here, bringing you another episode of Tazman Teaches Programming in Java. And in our last episodes, we've covered quite a bit of stuff. So we've talked about procedural versus OOP, we've talked about encapsulation, we talked about inheritance, polymorphism, and access modifiers. This episode, we're going to be talking about data types. Now, to help you understand what data types are, there's basically two types of data types. There's your primitive data types, which are also known as simple and uncomplicated, and non-primitive. Now, there's a lot more non-primitive ones than the ones we're going to go over, and we might address those later on in other videos, but in this video, we're only going to do two that we use quite frequently. So let's go and begin, and I'm thinking that maybe we'll jump to the whiteboard, or I guess the blackboard in this case. So what data types are and why they're important is because they actually tell the computer how much RAM you're going to be using. Let's go ahead and click here. So let's see, let me get on the right layer. There we go. So if you were to think of your memory as just a ton of boxes, and I need to be in a paintbrush apparently, Control D. So if you think of your computer memory as just a ton of boxes, right? And if you've seen my other episodes of teaching programming logic, you'll understand this a little bit better. But if we pretend this is a very, very small piece of memory, because when we're talking about memory nowadays, you're talking about millions and billions of bytes and stuff. Let's see if I can get 8 in here. No, one there. I think we might be okay. Let's see, that's 1, 2, 3, 4, 5, 6. And if we split this guy in half, we get 7 and 8. So what we're going to talk about is, first we're going to talk about those primitive types. Now your primitive types use up memory in very set, it's very, very, what would be the word? It's set, it's exactly, this is what it's going to do. So for example, we have our first data type is called void. And if you played Minecraft, you would know that void basically means nothing. It's null. There's no memories needed for this. It's completely blank. Okay? Then our smallest one would be a Boolean. And it's called a, let's do it right, Boolean. And this uses up 1 byte. So let's really quickly talk about, not 1 byte, 1 bit. Sorry. Let's see if we can actually get this thing to erase. Normally it doesn't. Usually it switches to something else. All right. So 1 bit. So one thing you need to understand first is what a bit is, what a byte is. B-I-T. So 1 bit would be just one of these memory locations. That is a bit. Oops, that's a bit. Then you might have heard also 1 byte, which would be 8 of these memory locations, which is why I split it up into 8. So that's a Boolean is 1 bit. Now, because this is 1 bit, it either is a 1 or a 0 because it's binary. And once again, if you don't understand what that all means, you should really check out my Taz Teaches Programming Logic series. It's only 5 episodes, but we cover all this stuff. The next one we would look at is called a byte. And 1 byte well, let's just say it equals 8 bits. Right? So that means in binary, you only have the option of 1 and 0. So that means in a bit, you could have a 1 here, or you could have a 0 here, but that's it. So generally, a Boolean is also known as your true or false, right? So it's either a 0 or a 1. 0 representing false, 1 representing true. Either there's something there or there's nothing there, right? Then when you're looking at a byte, you're looking at 8 bits, which means you can have a 1, maybe a 0 here, a 1, a 1, a 0, a 1, and maybe a 0, something like that. So this gives us a lot more information that the computer can handle. So 1 byte is, you can actually have the value from 127 to negative 128. And once again, this has to do with 2's complement. Check out my other video series of T4zzTeaches Teaches programming logic. You'll understand that a lot better, because we need to be able to handle both positive and negative numbers. This is giving us 127 in the positive to negative 128. And the reason for that is because 0 is kind of considered on the positive side. So there you go. Now, if we were doing unsigned, this would actually be 256. But we just do, we do signed with everything. Okay, our next one is a short. S-H-O-R-T. And this uses up, and so far, well, basically all your primitives, maybe null's not considered, or void is considered, I'm not sure. Void's kind of on its own because it's the absence of anything. You don't need memory for a null necessarily. So a short then is actually 16 bits or 2 bytes. 2 bytes, and that's 16 bits. So as you can imagine, this would be a byte. Oops, the whole row is a byte. Then this, that is the ugliest curly brace I ever seen, would be a short. So in this we can have numbers up to, let's see, what is it? 32,000? Negative 32,000, almost like 32,700 or something like that in the positive and negative. So let's just say 32,000. We'll just say thou, T-H-O-U. There's our U. So that's our byte, or I mean our short. Then the most common one we will use is usually called an int. Now, back in the day when memory was very expensive and it was not very cheap to write programs, you really had to utilize exactly what memory you needed. You might, you know, if I'm looking for a number between 1 and 10, I would do it as a byte, right? Or 1 even up to 127, I would say, do it as a byte. Nowadays, almost everything's an int because it's a huge number. If you actually need more, then you can do something else. But let's just go ahead and we'll say int. So we have our int here. And an int is equal to 32 bits, which is 4 bytes, right? So 32, whoops, I did that wrong. Let's say 4 bytes, which is 32 bits. And this is a number between like negative 2 billion and positive 2 billion. And you'll understand why I'm using numbers. These are all number types. So then we have that, which is 32 bits, right? And that's like negative 2 bill to positive 2 bill, 2 bill. And that, being 4 bytes, takes up that much memory. Now it actually goes a little bit bigger, so the next one we have is called a long, and it is equal to 64 bits or 8 bytes. 8 bytes or 64 bits. And this can handle a number between, I think it's like 9 quintillion in the positive and negative. I'm not going to write that anymore. Just remember what I just said. After that, now these are all integer type, or they're all whole numbers, which is what integer byte short. Whole number means it's a whole number. It can be negative, positive, but it's not a decimal number. It's not like a 1.5, that's a decimal, right? A whole number is any number that is whole, like 8, 32, 2, 1, 1, you know, all these are whole numbers we have up here. We also need to be able to handle our non-whole numbers. And so for that, we have something called a float, which is called also single precision, because it's not quite as precise as the other one. And it's 32, oops, I did that wrong. That's 4 bytes for that. Or 32 bits, 32 bits, B-I-T-S, bits, right? And then we also have one called a double, which is the same as your long, which is a 32-bit, or a 8, turn that in 8 bytes, B-Y-T-E-S, which is 64 bits. Now, when you hear about computers, you might hear, oh, it's a 32-bit operating system, 64-bit operating system. What this means is the processor can handle the 8 bytes, which would be, it can handle 1, 2, 3, 4, 5, 6, 7, one more. It can handle that much memory in a single pass, where earlier ones were 32-bit, which means it couldn't handle, it had to do like a double in 2 passes to do a single double. If that doesn't make sense, that's okay. We'll get into it later. Then the last one you might think isn't necessarily an integer type number or something like that, but it actually is. It's called a char. And this is a single character. And this takes up 16, oh, whoops, let's say 2 bytes. And 16 bits. So these are your 8, I believe 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So these are your 8 types of primitive data types. And the reason a char is considered, it's still a number because this is all a computer understands is 1s and 0s. And to get letters, we use what's called the Ascii table that converts a certain pattern of these numbers into a certain letter. So I believe an uppercase A, if I'm not wrong, is like 92. So if I said this is binary and said 1, 2, 4, 8, 16, 32, 64, 128. If I was trying to get the number 92, I would use one of those, which is 64. 64 and 32 is way too big. That's like 96, so that's a 0. We could do a 16, 64 and 16. I'm not going to go through it, but you'll see that we could get 92. I'm not going to go through it real quick because it'll take too much time. And we have a lot to cover. Like I said, or did I say, this might be a longer video than you're used to. All right. So these are our primitive types. Primitiv, primitive types. These are our primitive types right there. Whoops, let's get rid of you. And hopefully you kind of understood that. If not, this will be drilled into your head by the time we're done. So you don't have to memorize it. Just know that in programming, the ones you use the most will be this, this, and this is more of a return type that you use it for. Probably that, that, and that. These other ones you use under for special occasions. Float actually is pretty popular also, and we'll talk about that. But usually the byte, the short, and the long are special case only. Okay, so having said that, now let's talk about the non-primitive types. So these are more complex. Whoops, I need to go add a layer real quick. There we go. And now we need our non-primitive types. Now, for the non-primitive types, they kind of use the primitive types, but are more complex. So let's say non-primitive, non-primitive, primitive types. And we're only going to go over two of them, types. And the first one we're going to go over is string, string. A string, usually when you do a string, it's a group of characters, kind of, yeah, let's just say it's a group of characters. And to tell the computer it's a string, if I were doing an int, as you've seen in our programming, like if I did an int and I said this is my num, I'd say it equals, and I just do a number. I don't have to do anything special. With string, I do have to do something special. I have to encapsulate it within double quotes. So if I were to say I'm doing a string here, S, and it's uppercase, in Java, case matters. So if I were creating a string, I would say string maybe, let's call my num. My num. Or no, why would it be my num? This isn't a number. Let's maybe just call it name. Okay, so we would say string name equals, and then we would put in quotes what our value is going to be. Now this is still reserving a chunk of memory. However, a string will reserve however much it needs for the value of the string. Now if we talked about, remember we were talking about characters, so if I said T4zzM4NN, right? So what it's going to do is it needs to reserve 16 bits of memory here, or 2 bytes, 2 bytes. So it's going to know this is 2, 4, 6, 8. 16 bytes is what it's going to. Wait, did I say that right? I have to think for a second. Yes, 16 bytes. So that means this, to save in memory, is basically going to take up 16 bytes. Because each of these bits have to be. So it's kind of a grouping of chars. Now, one other thing I didn't mention with chars, if you're using a char, for example, say char like that, and let's say letter equals, usually you use a single quote and then the letter you want to do it. And that tells the computer this is this is a char. Even though this kind of tells it, and it knows that this is going to be taking its regular spot. Let's see, I want to, so that's kind of the string in a nutshell. Let's go ahead and just delete this real quick and go back to painting. Where's my paintbrush go? There it is. And hit Control D. So the other non-primitive that we're going to talk about is called an array. An array can actually be of any of the types we've gone over so far. An array is a collection of any of those other types. We could have a collection of strings. We could have a collection of numbers, integers, doubles, characters, whatever we want. We can do an array. So if you think about it, this would kind of represent an array of, let's say this is an array of integers, int, which means each one of these boxes is its own integer of, what did we say integer was? Wasn't it 32 bits? Yeah, 32 bits, which is 16 bytes. Or wait, is that right? No, I can't think. 32, no, actually it's 4 bytes. So that means it needs to reserve memory 4 bytes here, 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 4 bytes here. So as you can see, an array can take up a significant amount of memory because it's actually all these. Now the way we kind of do an array, or we declare an array, it's kind of, let's jump into our environment, our IDE. So as you can see, this is an array. I think I've mentioned it before. We're saying args is what we're calling it, and this is our array, and it's of type string. So in this case, that's what that is. So if we wanted to do our own array, there's a couple ways you can do it. One is we could actually say something like int. We're going to do a string of integers. And we could do it just like we have up here in the main where we're passing it. We'd say int, and let's just say a. Right? We could also, when you're declaring, this is called declaring a variable. This is called declaring a variable. What you're doing here is you're telling the computer, I need memory for an integer array, and I'm going to call that integer array A. But using a comma, I can actually also say, and I'm also going to do one for an integer array B. And that's it. Now the computer is only noting that you're going to be creating this. It's not actually saying, okay, I need to go reserve 128 bytes of memory for an array because I don't know how big it's going to be. So this is telling the computer, okay, I need an array. It might actually at this point go out and say, well, I know an integer is at least an integer is, you know, the 16 16 bits, or 8 bytes, or no wait, 4 bytes, and I'm confusing myself. So it might go out and actually reserve just that first one so that it can assign a name to it. And the name we've given it here is an A, and here we've given another array B. So it's going to go and think about setting up 2 arrays, one called A, one called B. Right? Now, there has been kind of controversy, or people talking that, is this more accurate or is this more accurate? Because this is saying I want an array called args. This is just saying I want a string array and I'm naming it args. In actuality, these are the exact same thing. So whether you do it this way or this the other way, it doesn't matter. However, standard says do it this way. So that's how I do it. That's basically the accepted standard. And the only time this would actually change is, let's say we had another one and we said int, and we say let's do a C, and we'll do that as the array, and let's say we want another, we're going to call D, right? Now here it's not going to be doing what we're thinking, because we have 2 integers. One's an integer array, the other one's not an integer array. So if you have multiple things you're declaring under the one data type, then it's best, if they're both supposed to be arrays, it's best to put it there, which is the standard. If you do it like this, what we're actually getting, if we come down here real quick, we could, for example, so this is declaring the array. Now if we wanted to actually initialize the array, we would say something like A equals, and we need to say it's a new array. So it's a new object or array, and it's an int, and we want that int to be, we want it to have 3 boxes, right? So this is 32 bits, so that's 64, and then 64, 32 is 96, I think. So this means this is going to say, okay, now I know A, my array A, is going to be 3 elements big, which means I need to reserve in memory 96 bits, right? Yeah, I think that's right. I keep losing myself. And then I could also do the same thing here and say, let's just do it this way real quick. C, V, enter V, enter V. Now this is going to have a hissy because we're declaring the same thing. But we could do the same thing with B here because we're declaring an int array, and our data type is basically an int array, and we're giving two variables the name. So if we do B and then we do C and we do D, we're going to see an error on D because D is not an array. As you can see, type mismatch. You can't convert an int array to an integer. So this is saying I want to take an integer and I want to assign it an array. Well, an array is multiple sets of that integer, so you can't assign multiple sets of an integer into a single integer. So that is what we call also, as far as error goes, this is called a syntax error, right? SYNTAXERROR. We're probably going to go over errors later, but there's three types of errors. There's syntax error, where you type something wrong, and the computer, if you're using an ID such as Eclipse, it'll draw the wavy line underneath it and say, hey, something's wrong. You're trying to put an integer array into an integer, and that just doesn't work. So that's called a syntax error. We're actually going to have another error in just a minute, and I'll explain that. Yeah. So here we go. We are declaring an array. Now, we're going to go over this in a little bit, but you can actually also initialize the same time you declare. So we could actually say, for example, let's just say int array E equals, but then we have to give it values if we want to automatically assign it. Then we don't need the new designator. So what we do with that is we use our curly brace, like so, and we give it our values. So if we wanted this to be a three element array, we could say 2, space 4, space 6, right? And that's legit. This means we have an array called E, and its elements, it's 3 elements long, and it has a 2, 4, and 6 in those elements. Now, one other thing with arrays is the first element is actually element 0. It always starts with 0 and then goes 1 and 2. So even though this is 3 elements, if we were to think, oh, I want the first element, it's actually the second element because the first element is 0, right? And we'll go over that a lot because we need to drill that in our head. The elements in an array always start at 0, not 1. So, okay, so that's very important to know. Then we could also, so this is actually initializing and assigning our values into our array. So this is creating an array of E, which is 3 elements, and those are the values in the 3 elements. So element 0 is 2, element 1 is 4, element 2 is 6. 3 elements right there. We could also do it more like this. If we don't know what the elements, we know how many we want, but we don't know what the elements are actually going to be. We can also do an int, do an array here, and we'll call this F. And we can say equals, and we can do it the exact same way we did down below. We can say new int 3, or whatever we want. We could go more if we wanted. But we could also do it this way. So we can actually assign how many elements we want without actually assigning values into those elements. And then in order to access that guy, all we would have to do is say which element we want. So we could say, okay, I want to assign into element 0. So we would say F and then our element number, and we would say equals, let's just say 3. Because it's an integer, we don't need quotes or anything like that. And then we could say F, and then let's do 1 And let's just count by threes now. Let's do 6, right? And that, and then we say F, and then 2. I have to really make sure I'm doing this right. And do 6, or 9, I mean. And then finally, let's do F. Oh, whoops. F bracket 3 bracket, and this would be 12. Now, I made an error here, and I actually did it on purpose. But as you see here, I have a third element. I have 3 here. This is a common thing where you think, oh, I have 3, so I can go up to 3. But remember, it starts at 0. Now you'll notice the computer's not complaining about this though. And the reason it's not complaining about this is because it's not keeping track of how many elements this array has in it. It knows there's an array as far as the IDE goes. You might have more advanced IDs that go into more checking and stuff. But as a basic thing, this is not necessarily an error. It doesn't consider it an error because, yes, it is an array, and I'm assigning it a value. I'm assigning one of the elements a value. That's all legit. What it doesn't understand is that that value, there's not an array slot for it. We don't have a third. This would be a 4-element array. So if we ran this right now, we would get an error saying Java Lang array out of bounds exception, and then it says 3, right? So this is telling me basically it's a 3-element array, and if I came in here, I could see at line 19, which is right here, I could say, oh wait, that is not good. So this is actually called a logic error, and these are actually the hardest ones to catch. I mean, this is a runtime error. Sorry, a runtime error. So that's a runtime error. And they're actually the easiest one to catch is probably syntax, because the computer catches it for you. You just have to go figure out why you caused an error. The runtime, it's pretty easy too, because it actually will give you an error when it runs. The third one that we'll go into these in more detail later, but it's called the logical error. And these are the hardest ones to catch because your program will work flawlessly. Well, not flawlessly. It appears to work as expected. However, it's giving wrong results. So a logic error is something like in some big equation, I added instead of multiplied, or something along those lines. So the results I'm expecting are not what I'm getting. So that's called a logic error. All right, so one other thing I want to do here. So remember we have strings up here. Well, you might be asking, why do we have this public static void main and then we have a string? Why on earth does it have to have a string? Well, when you run a program, you might have done things like in programming or in Windows, you might have done a ping where, you know, you say, let's see, if we pull up my command prompt here, I could go ping, and then I could say 10 dot, actually let's do 192.168.1.1, which is my firewall. So what I'm doing, ping is the program I'm running. This is called a parameter. This is what I'm sending to it. So ping is expecting me to send a parameter. If I type ping without a parameter, it will tell me, hey dummy, you need to give me a parameter, right? So I need to do ping, and I need the target name or target IP. These are all optional parameters that you can set. You could do a -t to have it go forever and ever and ever, or whatnot. So if we were, for example, we're gonna say, actually I have this already because it's a little longer. I'm gonna do this and just paste this in here. So as you can see here, we're looking at args0 and args1. Now, we're not assigning this. When I click run, we're not assigning args0 or args1, but I've actually modified this program, or the way it's launching. I've added an argument, and I wanted to show you really quick how you do that. So if we run this and save it, you'll see it actually says sub2 Tasman on YouTube. And that's because we're doing the string here of sub2. Then args1 must be Tasman because the next part is on, and this must be YouTube, right? So just to show you how you do that, if we want to pass arguments to our program, what we can do is we can come under the run, we can click the little down arrow and go to run configurations, and then we can go look at arguments. And as you can see, I don't have them numbered or anything, and I don't even need the quotes. I put those in. You would need quotes if, like I did, use space tube or something like that, because this would actually be one argument and this would be the next argument. If I do the quotes, it considers it one argument. But as you can see here, I'm passing when this program, so if I were running this program, which is called data types, my execution line would be data types space Tasman space YouTube, and that's what it's running. And that's why this has this, so that we can actually pass it arguments, and sometimes we want that, like with the ping. So there you go. Let me just see. I think in the next episode we're going to talk about variables, which is what we're assigning, the names we're assigning our locations in memory. We're at 36-ish minutes, and I don't want to go too long. But I think going over the data types, I think that was really good. I think we covered a lot. Hopefully you guys understood what was going on and what I was talking about. If you didn't, feel free to leave comments down below. I might have missed something. I've told you it's really easy to err when you're teaching recording and you can't see people's face, that they look confused or they're raising a hand or something like that. I need to get a drink real quick. I'm dying. Okay, so anyway, like I said, thank you so much for watching. I really do hope you enjoyed it. If you did, be sure to leave a thumbs up down below. Comment, like, and subscribe. Follow me on Twitter. Check out my other channels. And all the information for those should be in the video description. And until next time, I'll be seeing you later. Bye.